Start. Good evening, everyone. We survived till Thursday evening. Welcome to IETF 121 Rift, and Jeffrey and myself are going to start the meeting. So please make sure you've read not well, you understand your participation and adherence to IETF rules. The number of documents below in this slide, you better read and understand. So agenda for today, Jordan will talk about AutoSS, Changwon will talk about service extensions to Rift, and then Jeffrey will update on multicast. So we did a great job. Base spec applicability and YAML models are all in RFC editor queue, so we are almost there. New charter after a lot of going back and forth and wordings has been approved. A new milestone, and we are looking again to you to give your approval, disapproval on this. So we would like to submit key value data star specification for IGT publication by December or end of the year. Same goes for AutoVPN. Q1 next year, submit Rift for SS load reflection to SG. Segment routing specifically for MPLS to ILG publication, and then by end of the year, potentially multicast.
Tony P. Juniper. So short observation, this ISI's flood reflection, this will be now far more generic, right? Based on the customer pushing us. That's the auto ISIs. Mm-hmm. Okay, just so people don't confuse it.
So this is specific to the working group, right? Go ahead.
Yeah, this is Wei Chang from Channel Mobile. Here you said mentioned the segment routing MPRS specification, right?
Yeah.
We also have a draft about I76. Maybe you can change that for. Okay, you submit for publication, right?
Yeah.
Okay, I got it. So is that pass? Here is only the publication milestones, right?
Yeah, so those are the goals of the chairs, not necessarily what's exactly going to happen.
Oh, okay,
right?
got it. Thank you.
We've got best intentions, but so specifically to a service 6, I think it should be treated as a separate topic and separately from PLS. Oh, what's going on? So it should have. Okay. Jordan.
Does the clicker thing work?
Okay.
Okay, my name is Jordan Head. I wanted to talk about Auto ISIS, which was previously called Auto Flood Reflection. It's not totally showing here, but we have 2 new authors, Louis Tomataki and Brent Brockdorf from Verizon. So they'll be joining the draft in a more comprehensive sense for the next version. Okay, just quick refresher, right? ISIS flood reflection was used to improve scaling vectors in large single area level 2 networks, overflooding, LSDB size, SPF computation, so forth. Flood reflection was, for us, in terms of the implementation, a convenient first place to start. But this brings up why the name change. So not everyone needs flood reflection. Not everyone runs into network at that scale. It's generally speaking more applicable for more generic ISIS topologies, be it L1, L2, or a mix of both. Basically, the document was restructured, as Tony alluded to, in a more generic sense to let auto flood reflection fit in auto ISIS as a kind of a flavor. So we can address more generic things and have auto flood reflection as well, and maybe other things that come. Okay, disclaimer, and this kind of came up as a point of discussion during the rechartering. Everything in this spec leverages existing ISIS standards. We are not trying to step on LSR's toes. We're not changing any of the ISIS behavior there. And as we've done before with auto EVPN, auto flood reflection as well, or anything, we can share with LSR if there's value there.
Eventually, I think you should ask for time and present over there. Okay. And during the discussions about new charter, we got so many comments. Are you reinventing ISIS? Are you reinventing EVPN? No, we aren't. We really need to be clear about this every time.
Yeah, and it may be worth opening up the general architectural discussion as to how we use like the topological information to do the distributed computation and go from there. Just so they don't keep making the same, having the same misperception. Yeah. Next version will have a lot more meat to it, and I figure maybe 0.1 will be a good place for it. Okay, so now to the actual guts of it all. So what is auto ISIS, right? So it's very similar to auto flood reflection. It's basically identical, but so ZTP will bring up the rift fabric. You know, the lies will signal, you know, auto ISIS or auto flood reflection's capability and desire to self-configure in that type of topology. So in this case, since we're talking more generic, really the only major variables here that would be derived by the FSM and everything would be, you know, loopback address and ISO address effectively. So net and system ID. To deal with, you know, the desire for maybe nodes to be an L1 or L2 or a mix, we're going to use sort of device roles, which are also within the lies to kind of determine, you know, that particular node's desire, if you will. We do similar things in auto EVPN today. And then, you know, like all the other auto sort of implementations, we'll use, you know, key value for, you know, analytics information and, you know, maybe some aspects of simpler operations, some other things. Okay, just for those who are visually inclined, keep it very simple. So CTP derives all of the nodes levels in Rift. And just to be clear, this topology doesn't have to be, you know, that many stages. It can be something else, but just keep it generic. So ZTP will derive everything for Rift. The lie FSM will actually get the ISIS specific things for self-configuration, be it level 1, level 2, and so forth. And then all the adjacencies come up and it's magic, you have a fabric. So overall goal, and you know, you always want to have something more. One of the primary drivers of Rift was always you could just plug things in and it would just work, right? So why not take that sort of logic and apply it to ISIS, which is now very commonly used as chassis disaggregation, right? You know, think plugging in a switch, you can plug in a line card. You can plug in a spine, you get fabric and things like that. So we've already done this with auto flood reflection, but again, it was very specific to that use case, and that's why we're opening it up to make it more generic. Almost standards-based kind of disaggregation, if you will. Okay, a little bit more specific changes. So in the flood reflection behavior previously, we had stated where the spines didn't have to run it, but obviously we figured out that it has to, so it can figure out that it's an L1 node. So it's just a normative must now, nothing exciting. It was already implemented that way, but we codified it in the spec. Editorial stuff, references, spelling, phrasing, and so forth. I will say, and if you guys are good with it, given that we've kind of been waiting on the rechartering and everything, I would like to ask for adoption. I'm fine with pushing to the next version if we want to. But if we can put that on the list, that would be awesome. And as far as what's next, so right now, kind of the new renamed version 0's a little light in the detail, but we have the vast majority of it already done, right? The normative algorithms, it's going to use the same things as auto flood reflection with maybe minor tweaks. We have some key value stuff already. I have models built, but you know, I suspect we'll be adding more to cover if there are fabrics that want to do level 1 and level 2, we can kind of split those considerations apart and show, you know, how many adjacencies in either. We have to do the role definitions for the level determination. As always, we can do a Yang model. I know the base Yang model's in IESG right now, so it's good there. And then I think we already talked about sharing with LSR. Questions?
More an observation, Tony P. Juniper again, that multiple customers pushed us to do that, and they also on the draft. Some of them have lined up on the draft, they're helping out with it. Driver, yes, chassis disaggregation basically, but not primarily capacity reliability, but other drivers. But they have kind of found the same problem, and they didn't think the size will justify flood reflections. They wanted something flat with the option to go to flood reflection if things blow up too badly. So yeah, there's a real driver. We got poked by people to actually work on it.
So my proposal with regards to milestones would be new version with more meat,
Yeah.
presentation, LSR, and then we will call for adoption.
That's fine. Yeah. No.
Thank you.
urgency. Thank you.
One quick question. One of the slides show a very nice span leaf diagram there. I assume this thing works for arbitrary topology as well, right?
Yeah.
Okay. So it says that the resulting flood reflection topology is like this, but it really is applied to any arbitrary topology.
Not any arbitrary.
Yeah, not
it needs
any
a top,
arbitrary.
right?
Yeah.
It's still a rift topology,
It needs to be direction over.
right? You can do weird stuff as long as you tell where the top of the whole thing is.
Which, yeah, I mean, point of
Oh.
rift, you need the topological information and the hierarchical structure to get it. The only, off the top of my head, consideration would be is if you start mixing level 1, level 2 in really weird areas, but that's not really a problem with the solution. It's more operator and
Okay,
app,
so it
but
is still a fat tree topology.
Yes.
Yeah.
Oh, okay.
Well, because
I-
otherwise you simply cannot ZTP the stuff. You
Rift
cannot
has to
order the
converge.
whole thing, right?
Okay. I'm glad I asked. So Rift fat tree topology, but running ISIS as a routing protocol instead.
Correct. Yeah, that's basically what is the desire for whatever 1 million operational per reasons. Yeah.
yeah, rift is kind of manageability, and if you want loop back reachability, if you want stuff like that.
But so their chassis driver is small. They want to be able to plug an arbitrary leaf at any given point in time, right? Because once you have that, of course, there's a lot of interfaces on these leaves which don't run Rift. And then from there, basically service provisioning starts, which is not something we can solve, right? It is specific to the carrier, but that gives them the capability to build things which have weird speeds and feeds, mixes, which today with the chassis for them very difficult to achieve.
And something that's not in the slides that I probably should have put in is the goal of this, at least in its current iteration, is to, chassis, right? Customers still going to be customers, operators would still be responsible for provisioning their own services on top of it. Trying to do the distributed computation, especially with things like IPv4 and stuff, gets
right.
fun.
And then of course the discussion pops up whether the key value store will be used or not, but that's it becomes very much provisioning discussion, which we don't really want to get into because everybody has a different service model, they provision differently, and so on and so on. So the focus is really like, okay, so here is your fabric rule configured full ISIS. You don't have to touch. You can plug in, plug out anything. But then from there on, pick up the key value store. You know where your leaves are. Go provision your services. And we can use the key value store for it if you want. But I think since each of those service providers has such a different provisioning infrastructure, I think they'll never agree what we carry in the key value store.
Yeah,
right.
It'll
Even
get
as
heavy.
analytics, I doubt it, frankly. Right. And then we get also into this problem. It becomes really Yank territory because then you start to like, okay, so we can specify these key values should have these analytics, but they go in a box that doesn't support it. We start to build the Yank models on key value store, which I don't think that's any value.
simple and flat.
The analytics should be, is this thing working, right? Did auto fabric come up? Are the adjacencies up? That's it. From there on, you have your ISIS, and it looks like a chassis. Go provision, whatever you need the services. But we'll see how it develops. We know customers are driving it really.
Jim.
Yeah, I took my hand down because I'm like, I'm kind of struggling with the whole thing because I'm like, where did ISIS come from? It's like, why do I have ISIS in the picture with Rift? And But it's it's an individual thing. I need to read the document and stuff and talk to you guys outside of it. But if it's obvious, I'm not seeing it.
It comes purely from the customer demand. This thing replaces a chassis on their network that, for example, provides all this service on the access side. And they have all the tooling that desires that the routing protocol desires, blah, 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 blah. So basically, Rift here implodes into a ZTP mechanism for a disaggregated fabric. And that's the driver. But it's no further logic. You could say like, oh, no, Rift can function as a routing protocol, and we may end up there, right? So for example, with the flood reflection, when people start to do this kind of stuff and they start to realize like, well, why do I even run ISIS-L1? Rift could do the job just fine. He's like, yes. But, they like this ice cream flavor, which I can fully understand, and we cater to the public, So
no, I get it. It just threw me a little bit because I'm like, well, Rift can do all of this stuff.
Of course.
Why do I suddenly see ISIS on the slides? And I'm like, now I understand.
Look, I mean, if the idea of successful virus is whatever it takes. So if the host can be infected by this thing being a ZTP, well, that's the game we play. I should probably spell it out that way, but that's roughly what's going on.
Yeah, that's. I just thought I'd lost my mind, so I'm like now I'm clearer. So thank you.
Only partially, and SP's already lost the mind long time ago, so in sync.
Guys, my request is be very clear why you are doing this. Since you've got people who are going to use it, the better they describe the use case, the better it is. Be very clear about why you are doing this.
Yeah. Okay.
Thank you.
Thanks.
You have all the time you want. Don't worry about time. You can go above 10 minutes. That's fine.
Yeah, okay.
Turing complete?
Yeah, this is Taiwan Lin from New S3C. This draft is about the Rift extension for SRv6. First, we quickly review about the background. Using complexity SRv6 in data center may bring several advantages. Simplify the end-to-end protocol and enhance the DE capability and better SFC function and enable network programmability. By using SRv6 and X, it is possible to bypass congested node or links. For example, in this picture, when the SPI 11 become congested or the link between SPI and the leaf become congested, we can use the SRv6 policy to bypass the congested node or congested links. And also we can use the SRv6 complexity to offer the minimal overhead. This is the overview of SRv6 policy. In SRv6 policy may contain several candidate paths. Each candidate path may consist several segment list. Each segment list can consist by several SRv6. SRv6 and seed can specify the node forwarding, and SRv6 and exit can specify the link forwarding. Here is the comparison between IGP and Rift. For IGP, when we extension for SRv6, for example, for IGP, we may consist of 4 extension. First, we extend the SRv6 capability TLV and MSD TLV. Second, we advertise the SRv6 locator and locator's attribute such as SRv6 and seed. And the SRv6 locator attribute such as local block length and local node length, or the arc length and the function length. The third extension is about for SRv6 and X seed. We advertise the SRv6 the agency seed. The fourth path for IGP for BPL's extension used to advertise the link state information include SRv6 link state information through the BP protocol. For Rift, we may need the SRv6 locator extension and the SRv6 and X seed extension. We also need the KV-TLV extension. The change of this draft, the first presented at IETF 113, and we revised the draft according to the comments. We using the variable length KV-TLV for carry the SRv6 KV-TLV, and we use the prefix TIE to carry the SRv6 locator information instead of define the new locator TIE. Here is the overview of the extension for SRv6. First, we define the new SRv6 KV-TIE for JDP. The KV-TIE used to dispute the SRv6 locator informations with SRv6 and seed. And the SRv6 KV and X TIE will used to dispute the SRv6 agency seed. The second part, we advertised the SRv6 locator in prefix TIE. For the northbound, the SRv6 locator prefix and the SRv6 and seed information can be flooded northbound in prefix TIE. For the southbound, we may use the default prefix for the route to SRv6 locator. The third part extension is for the SRv6 agency seed. We define the SRv6 and X seed in node TIE, and it flooded to the northbound. Here is the SRv6 locator KV-TIE work mechanism. First, the controller will dispute the SRv6 KV-TIE to and flash to all nodes. Each node can update the SRv6 locator and the SRv6 and seed, and the SRv6 and X seed from the KV-TLV. This is the define of the new SRv6 locator KV-TIE. We define the key length in the SRv6 locator KV because the length of the key is limited, so we define the key length in the type. The next SRv6 locator KV-TIE used to carry the SRv6 and X seed. The define is the same. That we used the key length in the TLV key part. The second part is define the SRv6 locator in prefix TIE. When we flood the prefix TIE to the northbound, we carry the SRv6 locator TLA and SRv6 and seed. Here is the define of SRv6 locator in prefix TIE. We define a new type for SRv6 locator in prefix TIE. The third part, we define the SRv6 and exit by neighbor TIE element in node TIE. Finally, we can see the use case. The first use case when we running SRv6 with ZTP function. First, the controller dispute the SRv6 locator KV TIE to all the nodes, and the node obtain the SRv6 locator configuration and SRv6 and configuration. And then each node can establish the peer and report the node TIE to the controller. Then the controller can dispute the SRv6 and X KV TIE. And then each link can update the SRv6 and X seed. The next use case is without ZTP. For to the source, to the northbound, we flood the prefix TIE and include the SRv6 locator, and also include the SRv6 and seed. When we flood the node TIE, we also include the SRv6 and seed. When we flood the southbound, we just include the default prefix in the prefix TIE. That's all. Thanks.
Tony P, Juniper. So architecturally, yeah, all good. Jim, you want to go first?
Yeah. Okay, so I'm going to ask this because at some point or another, if this gets to me, I've got to justify it. And the biggest question that comes to my mind is, yeah, I can add all of this stuff into Rift. I mean, I can add whatever I want, but isn't the whole point of a DC fabric that you got oodles of bandwidth and you don't need traffic engineering? So have you provided any kind of justification in the document as to why you actually want this? Because if not, I think that's certainly something that needs to be there, because it's certainly not obvious to me. That's why I asked the question.
Yeah, Wu Qiangcheng from China Mobile calls of this draft. Yes, we will add some application scenario and especially requirements to the draft. I think, yeah, here, in fact, we give some example how it works. If you set up something like SRv6 T tunnel, you can implement something like adaptive routing, because the tunnel is already there. If the traffic might the congestion or link failure or something, other failures, it can switch over to the existing tunnels. I think that is a basic application scenario. Of course, we need to dig into that, give the clear application scenarios. Thank you.
Yeah, I think Wei Cheng, just in response, I appreciate the response, and what I think would be really helpful to clarify is that You know, if you look at Rift as from a protocol perspective, it's got a lot of inbuilt mechanisms to give you extremely fast convergence in the event of failure. So my scratching of head is, why do I really need this traffic engineering capability if I've got plenty of bandwidth in the data center where I can basically route around failures? I don't need to be setting up paths, traffic engineer paths. Of course, I could do that if I've got the extensions, but understanding why you would want to do that would be, at least to me anyway, useful, I think.
So Jim, Tony P. Juniper again, I'll help them. So what you're saying is completely justified, right? Like, why the hell would I bother? But there is actually one good use case where we, for example, see a lot of people using SRMPLS over UDP, which arguably is much simpler than this kind of stuff, but hey, no account for taste.
Right.
And it's egress peer engineering. So can you flip it
Okay.
back? Okay, I explain quickly what it means to people, right? So within the fabric, this kind of stuff is like, just buy more bandwidth. And that's how it will end up anyway at the end, because all these kind of things is just on the chip side, way too expensive.
Yeah.
But there is the case where a leaf wants to decide whether it ends up on TOF 1 or TOF 2 going out the data center, because
Okay.
above them the bandwidth is different, or class of service different, or blah blah, or whatever. And then there is actually no other choice but let the leaf to stick something on the pack. Like I said, SR over MPLS over UDP is a very good technology because it's just UDP, right? So within the fabric, you don't see anything. The
Yeah.
TOF strips it off, and you have an SR stack. So this use case, we say people applying, and there is no good answer unless you have something that carries this information through the fabric to the top. And
Yeah.
arguably this could be used, but it forces you to have SRv6 in every chip in the data center. Like I said, no account for taste. And then you can claim, okay, it's IPv6 anyway. I don't want to get into this game, but that would be a valid use case, I think, to add something like that. While all the fast convergence service, it all stands what you said.
Yeah.
But
So thank you, Tony. I mean, that's really what I'm looking for, is exactly what you just described. Is it, if the document can show, it doesn't need to show exhaustive use cases, but just one justification, such as what Tony just described, that says, look, this is why we're doing this, just makes progress in the document through the various processes that much easier. So I would certainly appreciate that, and I think it would speed up your document as it gets further along anyway. So maybe that what Tony described, you can get together with Tony and kind of update it for that.
Yep. So yeah, I support Tony's comment. I've seen it done with BGP, so it's absolutely needed. I like the approach. So architecturally, it's done right. I also like the fact that you didn't try to implement 127 plus their brothers flavors. You need lookup or use adjacencies, right? Those are two flavors that you need. Let's keep it this way. Let's keep it simple. We are looking into kind of tactical traffic engineering extensions only.
Yep.
Don't pollute stuff.
all right, so let's talk bits. So Tony again. So there is one where you fell flat on your face, needs to be talked about, and one advice. Let's flip a little bit forward, backwards to the encoding, what you were showing, where you would put things in, please. Packet formats, ASCII, PRON. Can we have the one where you have encodings? Because now I have to talk about bits. Wojciech? Can I have the bits encoding, like where you're showing the packet formats? No. All right, so now here.
Yeah.
So here you have a problem because there is tie breaking depending on the key ID. Read the spec. You cannot just go and arbitrarily define some kind of a key. If it goes northbound, it's still okay because you get all the duplicates at the very top and you can tie break. But when it goes southbound, okay, and two nodes show the same key ID, there's a tie breaking. on the guy who has whatever lower system ID or whatever. So if you send from 2 nodes this SRv6 type and the same key len, and the locator, the first 2 bytes of the locator and system ID look the same, it will look like the same key.
It will overwrite, right?
Well, you will just tie break,
Yeah.
right? Because it doesn't send southbound all the duplicates. Southbound, the key value store tie breaks. Because normally the way people use it is at the TOFs, they have backups. And both TOFs are sending south in case one fails, but you don't want to send both copies, right? But you all tie break and you just send one copy down. Otherwise, it doesn't scale. So here, go look at whatever the auto ISIS. Look at the key value draft, how it's specified. One after the next, right? So you have to get this somehow. You have to stick it into the key, right, and make it unique. That's a discussion. I'm just saying that won't work. The second one, there's something which we added specifically for this thing, right? Because there will be a lot of information on a big fabric, and you don't, maybe you want everyone to have all these values, but maybe you want to filter. Like only a specific node needs this stuff, going southbound. We're always talking southbound. So we put something which is a target, which is a Bloom filter, really. Gets detailed, but basically it allows you to say, I want this key value southbound only on this node. It's not perfect, it's a Bloom filter, but it will filter very, very well, which will allow you to scale this southbound key value store much, much better. But it's just an optimization.
It's not something you define in the draft, right?
Yeah, no, it's, yeah. We're doing stuff while you're not watching, while you were asleep. No, it is actually extremely useful because it will allow you to build a very large key value store, targeted key value store southbound, okay? Because, we're aiming for the end nodes, right, for the leaves to be as cheap as possible, right? So we can't just start to all of a sudden run like a SQL database of 500 gigabit, right? Because you may need one value, right? Okay, so that is a problem that we'll need to good looking at. And then flip forward, please.
Yeah.
Next one. That is all the same, but then
Yeah.
where you advertise it. Yeah, that's all okay. That suffers from the same problem. The rest is all okay, right?
Yeah.
But keep forward where you put it on the prefix.
Yeah.
On the prefix, on the prefix, on the prefix. All right, so this would work. It is semantically not clean because this is not a prefix, all right? Now, Rift allows very easily to add a new tie type. So just pull your own SRv6 locator tie type, and because the spec says if you add something which is prefix scope, you don't have to change the spec or anything. So basically, this thing will just get flooded, even if a node doesn't support any of that, right?
The intention of locator.
Sorry?
Which is the intention of locator? In general.
It is scope-wise a prefix, but semantically it's not. So let's not stuff it into prefix. Rift is architecturally built in a way that if things look like and smells like a prefix, but it's different semantics, you can just pull a new tie type and call it whatever, SRv6 locator tie type, and then just basically say all the disaggregation like prefixes apply. And you will have a clean architecture, much easier to debug and so on, yeah?
Can I add something? I actually had a question here. Why we need a third type? Well, to me, the locator can be just treated as an IPv6 prefix.
I think that it is much cleaner. Let's not pretend it's IPv6. It's not. No,
Okay,
it's not. If SRv6 would be a proper address family, I would say cool. All right, like it's a IPv4, IPv6, or SRv6, but it's not. It's a hack. All right, and let's admit that it's a hack, right? It's not an address family. Pull it, it's a tie type, and it has all the prefix, scoping, and that's cool. But it will be semantically cleaner. But it's a little bit of just elegance of architecture. If we wouldn't have a choice, okay, do it. But we have a choice.
So, but behavior-wise, if not doesn't support a service 6 and receives this update, it wouldn't properly process it, right?
It would. The base spec says if you don't know the type, keep on flooding it. But the base spec says you can only do that if it has a scope of a prefix.
Okay, makes sense. Yeah.
Right? So it will transparently go through normal Rift. Okay, we allow that. It has just have to have prefix scope. The spec says that specifically. And it's for this kind of things. So my suggestion is just pull a new type. Hey, cool, not many people get new type every day, right? And just the rest is all computes. I say it's just like a prefix, disaggregated like a prefix, all fine, all elegant, no problem, will all work. But it's just, will be more elegant. It's not an address family, it's something else. And that will also allow you later to maybe stick on the model weird things. Because, for example, the SRv6 locator, don't forget this prefix has certain attributes. I don't forget what it was. The loop back, is it redistribute that? And you'll be tied by this model. And if you pull your own type, then you can actually run your own attribute space modeling wise. It may be like SRv6 is always broken, attribute. Something like this, right? Which you don't want to stick on the v4 prefix because prefixes have this same attribute set. That's why decouple it. It's not an address family, it's something else, which is all fine. So that's just the architectural elegance. The key ID type breaking is totally broken, so that needs to be talked over, how to resolve that, okay? Otherwise, yeah, the whole thing computes. So those were the specific like bits and bytes, yeah.
Okay, thank you. We'll divide it according to your comment.
You have recording, otherwise you can run it about 1/5 of the speed.
Yeah, we will look into your suggestion and update the draft.
Yeah.
So from formal process perspective, let's make sure you make the changes proposed. You look into Young model because by now it's kind of mandatory when you do any routing work, and ask for time in Spring NAC IETF. Then we'll talk about adoption.
Yeah, okay.
Yeah, so we should apply a slot present the solution to Spring also, right?
Yeah, I mean, any words that Spring related eventually need to show up in Spring.
Okay, okay, thank you.
Jeff, just in case you haven't seen it, there's a comment from John in the chat that you may or may not want to respond to. I don't know.
Sorry, the chat.
I mean,
Jim,
since Jim name checked me, I just said I thought that Jim's questioning about the, what the motivation was a helpful question. I thought Tony's answer was helpful, and I would assume that that would end up in the draft because, I assume the working group would want that information during a adoption call.
Very valid comment. So please do provide motivation as to why you are doing this work. And again, practically, traffic engineering in data center is always questionable, right? You have enough bandwidth not to do anything, but eventually, especially if your connectivity model look like hyperscale, where you connect the super spine level further out of the metro, that might become valid use case.
So my understanding is that what you're presenting is a little bit different from the current draft. Is that correct? So the published drafts is a little bit different from what you're presenting here now. Is that correct?
Yeah, the latest draft is not published.
Okay.
Yeah.
If you could publish that as soon as possible, that will help people understand. Yeah.
Yeah, okay.
So I think we have a plan, right?
Yeah, okay.
Thank you.
Yeah, thank you.
So Rift multicast update is update from basically from a couple of years ago. We have not made any progress recently. I was going to talk about this in the last IETF, but we ran out of time, but that's fine. Today I'm going to just give a refresh on what we were, what it is about, the where we were. We hope we can resurrect the work now that we have finished all the base spec and people would have more bandwidth to consider this multicast. So yeah, that's what it has been stopped for a while. But we want to resurrect it, and this is a refresh of what's going, what it is about. So the Rift multicast, we basically want to use the bidirectional trees, similar to PIN bidirectional trees. The trees are well, it's more like the subtrees. Each subtree is rooted as a subtop. But unlike PIN bidirectional trees, we do not have rendezvous point addresses. Each node will just simply send the joins in the form of a ties northbound. You may have multiple northbound neighbors. You just pick one. You do some hashing to figure out which one to send to. The hashing ideally would give you a northbound node so that that node can replicate several downstream southbound nodes, but not too many. So it allows some replication on the up, but not too much replication. Eventually, the subtrees will end at the subtops, but we need to connect those subtrees through a spanning tree so that traffic can go from one subtree to another. Here is an example from previous from the slides from previous presentations. So here at the top, S1 through S5 are the like top nodes, and N1 through N5 like are the subtops. And so here, if you look at the orange lines, that's basically saying that L1 and L4, they hashed to M2 as upstream neighbor. On the other hand, those green lines shows that some other leaves hashed to a different upstream neighbor. The way we do that is what I said earlier, to allow the upstream neighbor to replicate to some, but not too many. Because if they all pick the same upstream neighbor, then that neighbor may have to replicate for many copies, and that may not be good. So we want to allow that flexibility. And then eventually you can see that N1 is the root of the subtree, orange subtree, and N2 is the root of the green subtree, and so on and so forth. Now, eventually we need to connect the N1, N2, and N4 together. The approach is to build a spanning tree through the tops and subtops to connect those subtrees. We talk about some ways to do that, but we didn't conclude that that way is sound. We want to have further scrutiny by the co-authors and by the working group, but complexity and the fear of potential problems, that's basically the start of the work. And the complexity and the fear of potential problems mostly come from the situations with badly broken connections at top and subtop level. So we are now considering to discounting those situations to simplify the solution and its proof. That's the things we were thinking of. So yeah, next step is we want to resurrect this work, and we want to get comments, suggestions, and collaborators. Tony?
So Tony P. Juniper, so it may be utter stupidity or an absolute flash of brilliance that I just had. This does look, I'm missing the man here in the room. It does look like flat optimization in reverse. So the TOFs, they have the information. I mean, they bounce off each other, the node ties, so they know who is connected to whom. So they can run an election, like you run a, rod reflector election for auto VPN, right? And they can decide among themselves, okay, no, we're covering that, but the guys below have to know that. So actually the guys below also have enough information. They see all the TOFs and all the TOFs, adjacencies. So they know which TOF covers how much. So they can run a distributed algorithm, basically picking their TOFs, saying, okay, with like one TOF may connect all the trees, or they can decide, oh no, it just connects these two guys, and I need to go to the other TOF to connect the other guy, and you basically you get it why it looks like flood reduction, right? You run of these candidates as many until you get a coverage and it's connected.
Okay.
And then would mean the TOFs don't actually have to advertise anything. The guys underneath run a distributed algorithm when they all agree, okay, this TOFs connects us, so forward to this TOF, and you have to replicate to those two TOFs and you get a full coverage. But it's basically, flat reduction in reverse. Okay. And Pascal's the man, so I don't know, he's bumming off because I've seen him, right? He's not paying attention to the stuff that matters.
Okay.
But I think bouncing that off Pascal may be the flash of brilliance that we need, because meanwhile, I was thinking through all these auto EVPN, where do you put exactly the stuff? And I also have it in my head. That's why we put the plane ID, by the way. Right? If you have multiple planes, it's like you want to distribute this thing across planes, right? You don't want everything in a single plane. So that may be the missing link that we didn't have.
Okay.
Or it may be total stupidity that doesn't work. So we'd have to talk that through, yeah.
Okay. So as I said, we thought of a way, but we were just not too sure if that works, and we didn't think of it from the angle of reversal of flood reduction. But now we'll think about that further. Right. Yes. Yeah. So we will pick up that again, and yeah, again, suggestions, collaborations are welcome. We want to get this work restarted. We believe the multicast support in the Fed tree network is valuable, especially given the AI ML applications nowadays. And pre-setting up the trees, I think it's a value solution because you don't have too many flows in the AI ML networks anyway. So.
Well, I mean, it would be a dirt cheap solution. We'll probably have to get a little bit smarter, because by gut feeling, the most likely application we can lure the crowd in would be to support in substrate computation. Like the trees were already the nodes to all the computations on the packets, right? And that would allow to set these things up fully automatically. And there is nothing that prevents this to set up multiple trees, right? As well. Yes.
Right.
Yeah. And no other protocol IGP space can offer this kind of stuff today, or after MOSPF failed, I don't think it's viable on the standard IGP to build those trees automatically. Whereas here, this would be a dirt cheap solution state-wise. Yeah.
Yeah. Okay. Thank you. So this is basically an update and a call for action to get it restarted again. Thank you.
I think it was a very productive meeting, great discussion, and I think we'll give you 6 minutes back. So thank you, everyone. I think we also identify a number of action points for head and SRv6 folks. Sorry, I don't want to mispronounce your name. Let's make sure that by next IETF we have something to discuss and there's progress. Okay. Thanks, everyone, and see you in Bangkok. So what you describe, you want to build more than one SPT?
Yeah, we can have. So the each tree will be for either a group or group prefix or a star.
Took some minutes, but I needed to improve it.